Okay, so in this tutorial, I want to show you how you can run text to 3D directly in Blender with a plugin so that you can generate 3D meshes textured from within Blender using this project called TRELLIS from Microsoft. First, I'm going to show you what the end result is going to be in a video that I pre-recorded, and then we're going to go and set it up so that you can also do it yourself. So here I'm in Blender and I am typing the prompt of the thing that I want to generate. And then after a while, it gets generated and added to the scene as a GLB. In this case, it gets turned into a Blender mesh, but different mesh. This is a buggy car, yellow. As you can see, it gets generated there. And so that's what we want to get to today. Okay, so first of all, what is TRELLIS? It is this project by Microsoft, USTC, and Tsinghua University that lets you go from image to a 3D mesh. And it's amazing. It works really, really well. And as you can see, it can generate pretty good results. And the code that's available, well, more like, the code that's available today on GitHub, it has the ability to generate an image, to generate a 3D model from an image, but not a 3D model from text. Although they offer it, I have created a repository that goes from text to 3D model using TRELLIS. And in general, this repository, although amazing, it doesn't have a Blender plugin. Neither it offers the ability to easily host the repository as an endpoint that you can use for applications. And so to obviate that, by the way, before we go on to that, let's try the Hugging Face demo, which I think is pretty cool. So this is part of the official TRELLIS repository. So we can pick an image from below here. Let's say this book. And we can generate. It's going to take a little while, about 15 seconds. And the first thing that TRELLIS generates in this demo, not TRELLIS, this demo, is a 360 video of the asset. And so here it is with normal maps. And as you can see, it did a pretty good job on it. And so after you've generated this, you can extract a GLB. You can also extract a Gaussian splat representation, but for the purposes of showing it in Blender natively, we're going to extract a GLB, and this also takes a little while, but it's going to get there soon. This is running on a A100. Okay, yeah. All right. As you can see, pretty good. Okay, so this is what TRELLIS does. It goes from image to 3D. They recently added multiple image to 3D, which obviously increases the accuracy of the model that gets generated, but it still doesn't let you go from text to 3D. And so let's go back to their project, okay? And so so that's what TRELLIS is, and so we would like to use it in Blender. And so the first thing we want to do is we want to go to this link that I conveniently have already opened here. This is a repository I created that combines TRELLIS, a modified version of TRELLIS. It's a fork that I made on a specific branch as well, that adds a bunch of stuff, of which the main ones are Docker files and Python apps to run TRELLIS as an endpoint, and a bunch of optimizations for the Docker files so that it can just be run and it works. And so in here, we combine a service that goes from text to 3D in a specific way, so that the images generated from that service look something like this. like this one. So if I were to say, I don't know, a mushroom house, I would get something that looks a bit like this, like it's kind of 3D looking with a soft background. And so this is what this part of the repository does. It generates an image from text with a specific look, given a text prompt. And then it passes that image to Trellis. And you can read the README. It explains how everything works and how it's all set up. But the gist is that there are two ways of running this project. One is by hosting it on a cloud-hosted GPU machine where you just run Docker from scratch yourself. So for that, you would use the Docker file options in the repository. Much more is explained down here. Or you can run it in serverless mode. I only built it for the RunPod serverless stack. So this serverless RunPod Docker file would not work outside of RunPod, which is a GPU provider that I've chosen for this demo. But you can just run the Docker file one. So the Docker file ones are universal. They can run on any place where you have an NVIDIA card. And they don't have to be cloud hosted either. You can run them locally on your machine if you have enough GPU memory. You need about 40 gigabytes for for each one of the services. And I'm going to show you how to set it up on RunPod. But this also applies for if you want to run it on AWS. It doesn't really matter. You can just run Docker directly from an EC2 instance with a GPU. And so the first thing we want to do is download the repository. We want to clone it, really, I should say. Clone the repository. And so you clone it locally to your machine. And here I've already cloned it. And I have it. Very important, make sure that you run git submodule update and init. After you clone the repository, because we want to download Trellis and all of its dependencies. If you're planning on building the image from scratch. For this tutorial, we don't need to do that. We are going to just use images that I have already pre-built for both Trellis and the text-to-image for 3D generation service. So the first thing we want to do after we have cloned the repository is build the local service that combines Trellis and the text-to-3D. To which Blender is going to talk to. So there are two Docker files here. You want to build a Docker file for the type of service you want to use. So if you want to use images that are hosted on, say, an EC2 instance or even on RunPod, but that are not serverless, then you want to run you want to build this Docker file. And so let's see here. I think I should already have it. So as you can see, I'm targeting the Docker file, this Docker file, and calling this something, and I can build the image. And what this app does, simply, it listens for requests from Blender or any really other application. It listens for a text prompt and outputs a 3D model by using first the text to image and then passing that image to Trellis and then finally giving you the 3D model. So it just combines the two. And this lets us build an application, a plugin for Blender easily. Once this is done, you want to then spin up the Trellis service and the image service. So right now I'm on a MacBook, so I'm going to spin these up on RunPod. But the same way that you do this applies if you want to run it on AWS EC2. You just need to run it on Docker there. So the first thing I did was I created two templates. I created a template for the Trellis image to 3D service with this Docker image. And I created another service with this Docker image that goes from text to image. And so we want to spin both of these up so that we can use them. So this is pretty straightforward. If you want to create a new template, you just go here, you call it something appropriate, and and you give it the Docker image you want to target. You can find them on the README. So if you want to run the local cloud ones, you want to use this one. I have a typo here, I'm going to fix it. So this is for the image to 3D. So you would take this, you would put it here, no credentials, it depends how you've done it. You don't need to override the start command. So here I would give it a good 50 gigabytes. And for volume disk, I would give this a good 300 because, this is going to save a lot of data. And this way you're not going to run out easily. Here, I think we should put a good, I think here workspace is fine actually, and we want to expose 8,000 actually as well as 80, but that's okay. Cool. Environment variables, very important for the image to 3D. Text to 3D. We want to add a HF token key for Hugging Face because this image is going to download the Flux and Flux dev models and other LoRa's that are gated behind an API key. So you need to put something here. You can get it from Hugging Face. And I will leave a explanation on how to get this key in the README for the repository. But once you've gotten an API key from Hugging Face, you can pause the video now, I guess, and go get it, and then come back here and put it here. Once you created an image, the bottom line is that you'll have these two things that you can spin up very, very quickly if you need to. I have also created volumes, and volumes are persistent storage for the pods and the serverless deployments that allow you to pre-cache the Hugging Face models, essentially. That's the main thing that they offer here, because the Flux models are pretty large, and also the TRELLIS models can take some space after they're compiled. And if you have persistent storage, you don't have to re-download them and reinstantiate them every single time that you spin up a pod with these images, really, or run them in serverless. So I've done that, and that's very useful. That's been very useful to me. So that when you spin up the pod, it doesn't take forever to download the images to download the Hugging Face models and to compile them. So after we've done that, and we have some storage, and we have the templates with the images that I told you. So this is the image for the headless version of TRELLIS that I built. It's a Dockerized version that's headless, and the Dockerized version of text to image. We can deploy them. So let's say I use we're going to do the text to image, and I am going to pick this GPU because it got enough VRAM and it is pretty cheap and it does the job. So we only need one, and this all looks good. So if we wanted to, that's cut off, that's okay. If we wanted to modify this, we can, but this is an example of what it should look like. And then we can deploy it. We also need to deploy a second one, the image to 3D. So I'm going to pick the 3D Gen RunPod image. I'm going to pick the same type of GPU because it's, like we said, it's enough VRAM and fast enough. And then we are going to deploy it. While these load, I want to talk to you about the serverless version of all of this that is running these two are running the exact same images, Docker images as these two, only that they are deployed as serverless. Let's call them functions. They call them workers in RunPod. And the difference here is that you pay for the usage and not for the uptime. And so this is useful in case you're running certain types of workloads. And so if you want to have them up and only occasionally use them, this is a good option for where to deploy these services, so that only when you make a request from Blender, for example, or anything else, any other service, you pay for that and not for the pod being up. But they are equivalent. They are functionally equivalent to these, with the difference that, like I said, there are 2 different Docker files per type of deployment, simply because the way that serverless deployments work in RunPod, they can be run asynchronously or synchronously, but they're better run asynchronously when the jobs that you dispatch take a while, versus the pods, the fast API versions that I'm deploying here, they run synchronously. So when you make a request to this endpoint, you wait until it gives you back a image, and then I think we have deployed the same image actually. So I'm going to stop this. Yeah, let's stop this. And what volume? Trellis image gen. Yeah, so that's fine. So let's 3D gen. Yeah, let's pick the 3D gen here. And this. Yeah, you see, because it keeps the last one, so I need to pick Trellis. That's fine. Okay. Anyway, I think you get my point. So now we're going to wait for these two, for these guys to be initialized. In the meantime, we can go and we can look here at the nothing. Just gonna wait. So after these have been set up, you want to read the sorry, this is the wrong. You want to click here and click on HTTP service port 8000. It's not ready yet. It's about to be. And you want to take note of that and go to your repository again that you just cloned. If you don't have it, you want to create a .env file. In this case, I have 2, one for the serverless and one for the normal deployment version, in which you're running Docker manually, like I just did. And you want to put them here. So this was for, let's see, the image to 3D version. So the model service. So you want to paste the URL here. And for the image generation, we want to do the same. So we want to go here, we want to read this ID, or, you know, click on connect. Of course, this is not gonna work because it's not the right endpoint, but we want the URL. And we put it here on the image service URL. Just to show you, if you were running the serverless version, you would have different environment variables to specify, and you would get these IDs from here. You see, this is an ID and this is the other ID, and you would put them in. You would put them in their respective correct positions here, and you would also need a RunPod API key to use. So, okay, so we have set up the environment variables. We have built the image, and now we want to run it. So we want to go run the Trellis end to end. We want to expose port 8000, and we want to use this environment variables here. These environment variables. We want to run it. So now this is listening now for connections, and it's going to run the service end to end. So let's triple check that everything is running again. This is still built. Okay, now it's listening. Perfect. Cool. The image one was already running, I'm sure. Yeah, it's listening on 8000. Cool. And then we want to start Blender. So you launch Blender, and then you go to File. You go to Edit Preferences. You go to Add-ons, and I'm going to remove this so that I can show you how it works. You would arrive here. In this case, I have Blender 4.2.3 LTS. You click on this down arrow and you click on Install from Disk. You go to wherever you have saved your repository that we cloned, and we want to select text to 3D add-on. Once it's there, it's installed, and provided you follow the steps that I showed you before until now, you can click on this little panel here and then text to 3D. The API URL is the URL of this service, the combined service. So if you were running this on a remote machine, you would put the URL here, and you only need an API key in case you want to gate it. If you don't give any API keys in here, for example, if I went in like API keys, I could specify like ABCD, whatever, and it would be gated behind that. But in this case, we didn't do that, and because we don't need it. And then we need to give it a prompt here, text prompt. It's a bit cut off, and we say a dragon. You can modify some parameters here. I think this is fine for now, and then you click generate. And you should see here that the service has received a request and it's now generating an image. We can go and see that this is happening here by looking at the logs. GPU utilization 100%, so definitely something is happening. So this I think has run now. Maybe it's finishing. And once that's done, it's going to then generate the 3D model and then put it in Blender. It takes a little bit. Oh, there we go. Here's our dragon. Let's turn on the material. So it did a pretty good job after all. Probably the image was like this, you know, and it did the best that it could on this side of things. I'm pretty sure it was something like this, the image, but still pretty good. And we can try another one. Let's do a pickaxe. Nice. This one is actually pretty good as well. So that's how you use it. Enjoy.